Hey everyone, welcome back to this series titled A Very Opinionated ASP.NET Core Architecture. This is session number 5, Basic Implementation. So, up until now, we've kind of just been doing some basic, starting out stuff, right? The stuff you would do within the first hour or so of creating an entirely new project. Today, we're actually going to make that code. Woo! Finally! No more fake data just being returned by those controllers, right? So we're going to go ahead and implement those controllers to actually create those ratings and load them using GET requests, all that stuff. We're going to go ahead and do all of that locally. So even though later the plan is for this application to be hosted in Azure, right now it's still just going to be run on my local machine. So no Azure, no cloud, none of that stuff starting up. We're also going to go ahead and add our unit tests. We don't have any yet so far, so we'll go ahead and throw those in. All right, and as always, like I've said before, everything I'm saying right here, this is a very opinionated way of creating ASP.NET Core applications. I am just shouting into the void here, telling you all how I like to do it. You don't have to do it the way I like doing it, but I don't know why you've made it this far if you haven't at least liked some of the things that I've been saying. But yeah, not everything here is for everyone. And again, if you have any questions, comments, concerns, insults, sexual advances, whatever, just, YouTube comments right here. Find me on social media, Blue Sky or LinkedIn. Links on my site, programmerall.com. I will deny any of the sexual advances. I am married, so just throwing that out there. I would prefer if you didn't send any. Don't be gross. Okay, with that out of the way. That was a joke I shouldn't have made. Anyway, hey everyone. Yeah, I do regret making that joke. Let's just forget it's there. It's a lot of work to go ahead and re-record the intro, so I'm not going to do that. But I am just going to say, as a PSA, don't be gross or weird to people on the internet, especially if you don't know them. So, PSA done. All right, cool. Hopefully that's the only edit I have to do for this video. I guess we'll find out. So, like I said, today we're going to go ahead and just actually add the real code to our application. I've already done that. It's kind of boring, I think, if you watch me write out all of this code. So most of that is already here. Unlike the previous videos where I would just start with the same code base as before, I'm starting with the same code base, but I've already added the code. Most of the code, not all of it. So the code that I have added is the actual implementation. So here we are in our get endpoint that we implemented or that we created in the previous session. And right now we're actually going to go ahead and just look at the code. Let's review what we're doing. So in our method right here, our get up, when our get comes in, we're actually gonna, in addition to our request, we're also going to receive an instance of this ratings service, and then we're going to go ahead and use that ratings service down here to get the actual values. We'll look at that code in a second. But when we get that response, we're going to go ahead and create, or we get that result, sorry, we're going to go ahead and create our actual response. So just like before when we were faking it, now we're actually going to go ahead and use the actual data from our database, essentially, right? So get the data from the service, create the object that we're returning, and then actually return that object. That's all we're doing right here. Now, the rating response object down here, just a reminder, right? We're using a very specific object for our endpoint, for that get endpoint, which means that the service is returning something else. So this goes back to what I was talking about before of if something is returning some object, a lot of times you want it to be very clear why that thing is being used, right? So that's why every request response is going to be per endpoint, and sometimes we're not going to share objects within our services. Sometimes they will be different. This is a very simple setup right here, so as a result, it's very easy to not share them. So sometimes it's hard, or we're trying to we want to share code, we want data to be similar for some method calls but not others, so that part gets hard. But I do think that spending that extra time to really decide when it is better to share a class versus not sharing a class for the response from a method, I think that is well worth it to just go do that back and forth in your head. If you need to draw it out on pen and paper, whiteboard, whatever it is you use, definitely do that. So since we have this, let's actually, before we look at the rating service, we're going to go ahead and look at the post because it's very similar. Same concept, we're going to receive an instance of that rating service when we go ahead and when that post comes in. And then we're just going to go ahead and forward that data onto that service. So we're going to call the store new rating async method, and then we're going to pass in the rating. And one thing that is actually different is we're going to say, hey, our post, the request that comes in, we could actually get a null value for comments. We're letting that happen. We think that as far as our interface to the outside world goes, it's okay if this is null. However, internally, we're going to be very strict about it, and we're going to say we don't want to use null anywhere. So we'll look at that right here, actually. So if I go to the definition of this method, store new rating async, we're not accepting a null value. I could, if I wanted to change it, I can say, hey, this can be a null value, and then we have to propagate that throughout the rest of our code base. Or we can just say right here at the periphery, right, the edge of our application, we say, no, this has to be a non-null value. We're going to guarantee it here, and then we don't have to worry about it at all in the rest of our application. So this is kind of going back to something I said, I think back in episode 1, where I was talking about the nullable references, right? We have enabled nullable references, and then separately, we're treating our warnings as errors. And so that is forcing us to deal with this nullable value right now. So personally, I think this is great. It's less work in our minds as developers. It's less stuff that we have to keep track of. So I know that when I go to this method, this cannot be, or this variable right here, comments, cannot be null, because we have done that check. We've verified that, and the compiler is checking that with us too, right? We just don't have, well, while it is possible for that to sneak into code, we've done the basics. We've made sure that it's not going to be null. All right, null tangent aside, let's actually look at it. So, hey, we have our rating service, the thing that we were using both in our get and our posts. So notice that this is using an interface, and yes, I did put the interface and the class in the same file. The interface exists only for this class, and honestly, the interface exists only to make it easy to write unit tests. That's kind of it. This is one of those things I know some people debate. Hey, should we make interfaces all over the place, etc., etc.? I think from a unit test perspective, it's simple enough. We are going to be implementing unit tests in a bit, so I just wanted to point out that yes, we're putting these here in the same file. In a later video, we are going to simplify this a little bit more, and I'll show you what I mean by that. But for now, I just want to call out, I do like this pattern of putting the interface and the class in the same file, specifically when the interface is just for that abstraction, right? That's all it is. It's just for this right here, for being able to unit test it, stuff, or unit test other things, right? Not specifically the rating service. All right. So in our constructor, we receive an instance of the repository, right? So we have some database stuff going on. We'll look at that in a second. But as far as our storing new endpoint or storing new ratings and getting them comes into play, it's pretty simple, pretty straightforward in terms of what you would expect, right? We're going to go ahead and call our repository. When we're making a new one, we'll call our repository. And if there's an error, we're going to throw an exception. We'll just do that here, guarantee everything's fine. A smarter thing, to be honest, would be to kind of let that propagate up. But I feel like a lot of times that code gets really messy when you get a couple of layers deep, because then you have to keep returning that. I think in this scenario, this isn't bad. We have our custom exception. We're logging that exception, or observing our collection with that middleware that we created back in episode 1. I think in this scenario, this is fine. Similar thing over here with our get rating. We're going to go ahead and call our repo. We'll send the query, which isn't really a query. We're just going to say how many we want. And then we're going to go ahead and take the actual entity, the thing that is created, the thing that's returned for us. And then we're going to create a different object, the query rating. So we're just going to loop through that list, make the new thing, and then return that up. That's it. That's all we're doing. Now let's actually look at the database, the repository class, right? So here, same as up above, we have our repository interface, and then there's the repository class. Cool. We have the basics there. It looks like we have our config going on right here. So we're going to be passed in an object of our storage config, and that's going to be used a little bit later. So storing is just going to go ahead and create a new entity and then add it to our table storage. If you're not familiar, so we are using Azure Table Storage. Azure Table Storage, it's really nice for small, simple things. It's not a traditional database in the way that you think of it, right? Because it is very much a serverless kind of thing. It's a or PaaS or one of those fancy words, right? For cloud services. Table storage is a document style database, right? You're storing JSON essentially. That's what we're doing, storing JSON objects in some persistent store. That's it. That's all it is. It's very cheap, and if you don't need a lot of database type features like backups being a big one, relational queries, stuff like that, table storage is good. I love using it for a lot of these samples just because I feel like it's really simple. It kind of feels like it's built for that kind of thing, but I have used it at work before for miscellaneous smaller types of applications. All right, so that is storing a new entity. Down here, we're going to go ahead and look at our get, and same that we're just going to use the table client to query and pass in the max count. That's it. Both of these have a load table client, so let's look at that method just kind of to call it out really quickly. We are using the SDK, the Azure SDK, just to call that out over here. We added the NuGet package for that to be able to get it, azure.data.tables. And so with that, with our table client, we are passing in the connection string from our config and the table name that we're actually going to go ahead and load from. So for now, we are using a connection string. In the next video, after this one, we're going to change this up to be a little bit more secure, so we're not using a connection string, but that is a separate concept altogether. So I wanted to call out that we will be improving this. Anyway, with that, that's it. We're just creating a new instance of this. We're making sure it exists. That's it, right? Just the basic stuff. And that's it. That is our that is our application. That's our implementation. There's a couple of other things. For example, program over here, program CS. We are doing a couple of things. We have added our config. We've added our service, our repository, right? We got to register with our container. This I do want to call out as far as our config. And actually, let me go to the config over here itself. So you probably saw the storage config that we're passing into the repository. Notice we are doing a couple of things here that we have kind of talked about also with our endpoints, right? So if we look at our endpoints, right, we're saying certain things are required. We are required if you're newing up the object, or required with the attribute, right? Stuff like that. We're doing that same thing over here with our config. We're saying, hey, this is required, it's not null, and actually, you know what? I did make a mistake. I should have done this. Required. There we go. Because if we're going to new up an object, we'll require, like if I were to type out the code right now, that that's where this required would come into play. But we're never going to do that with this object. We are just going to deserialize it from config, and that's where the attributes come into play, right? So in this case, we're good. Now down here, what we're doing is we're telling .NET, when the compiler, we're going to say, hey, there is a really cool source code generator built in using that knows, hey, when I have this pattern, it's going to go ahead and generate the code that does the validation of this. And so that's why we have this partial class, right? We have this attribute, and we're inheriting from some stuff. And so .NET at compile time is going to go ahead and actually generate all of the code for this. And I think, you know what? I wonder if, well, let me go back to program CS as an example. Can I F12, if I go to the definition, this one? Yeah, here we go. Yeah, this is the generated code. You can actually go ahead and look at it. This is everything it's doing, right? It's checking. All right, we have a property. We're going to make sure it's not null or empty because of those rules, that kind of stuff. Same thing with that table name. We're just requiring them to be there. So that's what we're doing right here. And then when we register that config, we are saying validate on start, meaning on startup, just make sure that that we actually have that value. So looking at the config over here, I'm going to go ahead and open this, and it looks like I made a mistake. I did not copy paste that over. I'm going to go ahead and copy paste from, oh, nope. Oh, that's right. That is not set there. We'll set that separately. Okay, cool. So, oh, no, nope. I was looking at the wrong file. That's me. That's what I get for having the same solution open on multiple places, just to make life easier for me to copy paste. All right, copy paste. So this is the config. This simple, right? Our storage config. That's it. That's the main implementation. Now let's actually add stuff to it to be able to run this. So you're probably looking at the storage config and you're thinking, that's not right. We're only setting one variable, table name. If I go back, we have table name and connection string. Well, why aren't we setting the connection string here? It's local only, right? We're in our .development config. We don't need to worry about, leaking a connection string if it's in our development environment, local environment, right? That's fine. And I agree with that, but we can go a step further, and this is where .NET Aspire comes into play. So let's go ahead and open .NET Aspire. Now, actually, I'm going to go ahead and copy paste a NuGet package before we get too far, because I keep forgetting to add those in. And we're going to go ahead and add this spire.hosting.azure.storage. Now, this is the NuGet that's going to go ahead and let us add the Azure table storage on startup. And so now I'm going to go to my Aspire program.cs, and I'm just going to go ahead and copy paste a bunch of code that's already here. Copy, Control-Alt, paste, perfect. All right, so we have added some stuff. So first off, we're going to go ahead and tell Aspire that on startup, I want you to go ahead and add Azure Storage, but the emulator for Azure Storage. And separately, we're going to go ahead and create a table storage instance, right? So Azure Tables, perfect, right? That's what we're using. That's how we're storing our data and getting it and all that stuff. Now down here, we're going to go ahead and tell Aspire that, hey, I need to inject an environment variable, and the environment variable is this one, storage config __ connection string. If you haven't seen that before, that's how you make an environment variable, the underscores, right? That's how you make the environment variable for this kind of JSON nesting, right? Because remember, in .NET, config can come from multiple sources, not just a file. It's, environment variables or whatever custom stuff you want. So here we're using two of those, right? We're using this JSON file, and we're going to be using an environment variable. And so we're just going to pass in the connection string that is created for us. So it's just automatically there. And in theory, that's everything that we have. So cool, our build succeeded in the bottom left. So I'm going to go ahead, hit F5, and we'll go ahead and start this application. We'll just do a quick test. So looks like, perfect, everything's up and running. Our table storage, that's perfect. We'll click on our app. Let's go to Swagger like before, and let's actually test this out. So I'm going to go ahead and say, looking good, with the 3 exclamation marks. Cool, we'll go ahead and execute that. We get our 204. That's perfect. That's what we wanted. And let's minimize that. And let's go ahead and try this out. And I'd say, 3. Only 1 will come back. But cool. Hey, there we go. There's our rating of 5. Looking good. Perfect. This is working. Awesome. That is exactly what we wanted from this. And so we'll go ahead and close these and stop that. All right. Perfect. So that is our application. That's our code. Awesome. But we're not complete. In my mind, code is not complete until it's tested. And one of the ways that we test it is with unit tests, right? We have to do this the right way. We should be doing this the right way, right? And so one of the questions always comes in is, how much do we test? So we'll talk about that in a second. But first, let's go ahead and add a new solution folder. Let's actually add a couple, just because things are starting to get a little crowded. All right, so we're going to go ahead and move this into app, and we'll leave Aspire out and our tests. So we're going to go ahead and add a new project. You can go ahead and use whichever one you want. Really, it's just a preference thing. I like XUnit. I started using that one years ago. I like it. So I'm going to call it Unit Tests, and we'll use all these other defaults. Perfect. That's fine. All right, cool. Let's delete this standard one right there. Now, there are some packages that I like to use. Looks like we already have a few there. I'm just going to go ahead and copy paste from my other solution over here, and just so we have everything. Plus, that other one I'm copying from, I've already updated some of these NuGets. So we'll build. While that is building, let's talk about some of these. So there are 2 specifically that I've added to this. So XUnit, we're using Shouldly. If you haven't heard of Shouldly, I think a lot of people have heard of Fluent Assertions. Shouldly is very similar to that. I really like Shouldly. I've been using it for years. The thing that I like about it is it's in my mind, it's easier to read. One of the benefits of something like fluent assertions is that you can assert an entire object, but the way that you write that code, personally, I never liked it. I always thought it was really clunky. Shouldly isn't much better. Like I think it's a little bit better because you're going to be testing like one property at a time, which is still a lot of code. You'll see an example of that in a minute, but I like it. That's what it comes down to. And then separately we have nsubstitute. So nsubstitute is it's a mocking framework. So just like I don't know, Rhino mocks or mock MOQ, right? Nsubstitute is just one that I started using. Use whichever one you want, really. That as long as it works, right? As far as unit tests go, as long as we can mock things out for simple unit tests, we're good. And then notice, just because I'm here, I added the nsubstitute analyzers package. So remember, we were talking about analyzers before, back in episode 2 of this series, when we were setting up all of our editor config stuff and all of that. So yeah, let's just throw those analyzers in here just to make sure we're doing things a somewhat correct way, right? So cool. All right, so those are our that's our unit test setup. Now I'm just going to copy paste some folders over here just for simplicity, and we'll look at these. So far, I've only actually added the tests for the rating service. Now, look at the rating service. Oh, oops. Let me add a project reference to that. There we go. Should be able to build now. Okay, perfect. So we can build. All right. So we've only implemented the tests for the rating service. And the reason for that is because as far as unit tests go, you should really, in my mind, you should really only be unit testing logic, application logic. If you want to test database connectivity or something like that, well, that's more of an integration test, right? At that point, you should be testing the whole lifecycle of the application. But a unit test should be that smaller unit. And so that's why we're really only throwing these unit tests in. So as far as unit tests go, we're going to go ahead and do some basic setup right here. So here we're creating an actual instance of rating service, but we are passing in a mocked out version of that ratings repository. So we're going to go ahead and just control that value before, and we are going to have the that repository just use a default value. So let me scroll all the way down here to what that is. So that's set store rating results. So if we're going to go ahead and store a new rating to add a new one, we're just going to go ahead and pass some. Basically, this is the default value is what we're doing, right? So we're setting up a fake object, and then we're going to say, hey, just whenever it's called with any values, just return that one. We're just going to default to it, and then we can go ahead and change it in some of our methods. So let's go ahead and talk about that fake right now. So when we are going to go ahead and store a new rating, so let's go here to the rating service, right? So here we go. We're back at the rating service. If we actually go to the repository, notice is returning an Azure-specific thing, right? And that's true of even when we're getting the values, right? This is an Azure-specific object. And if I go to the definition, that is an abstract class, right? The response. And same if I go to the definition down here for the async pageable response, right? When we're getting values from the table. Whoops, that is wrong button. F12, not Shift F12. So here again, another abstract class. And so that is, unfortunately, that makes some of that unit testing stuff harder because we end up with two options. We can either make a mock object, which is, this thing right here, this mock, substitute, whatever. But then we have to mock out each individual property, or we can just make a fake. And if you're not familiar with it, a fake over here is something like, my Azure response fake, so it inherits from that abstract class, and we're just going to store some things, right? So we're overriding all of these defaults. We're just setting some default things. We're going to override, a little bit of logic. We're just doing whatever we need to for our testing, right? This isn't a fully fledged class. We're not making, custom response. And then we're going to go ahead and just add some, fake, some helper methods, right? So we have this helper method to set the return values, right? Like the HTTP status and the reason phrase. And then we can also call that from the constructor, which is something that we do in that other method, that part of that test that we were looking at. And so that's the purpose of the fake. And we do a similar thing over here with Azure Async Pageable fake. This one needs to get a lot more complex just because there's like multiple objects. It's a little annoying. I'm not a huge fan, but that's the world we live in, unfortunately. That's just how we have to deal with that. All right, so let's actually look at some of these tests. All right. I'm embarrassed of this first one, and the reason I'm embarrassed is because I'm not actually we're not asserting anything. We really should be asserting something when any test is run. But because this endpoint is very simple, right? It's store a value, make sure we don't error. That's it. We're good. We know because in our constructor up here that we are defaulting to 200. And honestly, what we probably should do, we probably shouldn't have that. We should set that here so we know for an absolute fact in our test that this will be a 200 complete. But we are relying on the fact that as long as we make it out, we're good. And that's it. That's really all we're testing. Now, we also have another one where we are going to go ahead and override the response. So we're going to say, hey, the response, the status from the repository says, hey, we have an HTTP 500 error. And so we should be throwing exception. So cool. Yeah, let's go ahead and assert an exception gets thrown when we go ahead and call this, right? It's the same input, but we changed the mocked out value. So simple there. And lastly, we have our get request up here. This is where we're really showing off shouldly. So we're going to go ahead and create our fake response. So our fake, async, pageable, whatever. We're passing it in. What are the two actual values that the repository is going to return to us? We have to actually use our mock object to do that. We'll call our get, and then we have to do a bunch of asserts, right? So we said, hey, give us 3. But we're only returning 2, right? We know that because up here we are only telling it to return 2, and that's fine, right? That could very well be it. That I'm sure that is a standard, a standard thing in a database, right? Maybe someone requests 10, but there's only 2. It's not a popular thing to be rated. For example, these videos, so something like that. So hey, let's make sure there's 2, and then we are checking each individual property on both of the return things. So, yep. And as far as unit tests go, that's pretty much it. They're very simple, right? Like I said, they're very, very basic. I do think that there's a lot of room to really improve some of these, and I know there are frameworks out there to generate some fake data as far as our unit tests go. One of the problems that I've had with some of those fake data things is it's a little easy as a developer to rely on that too much, and then you end up testing just the data itself and not testing your actual code. So I've had to actually go into code bases and fix that before because, when you're writing a bunch of unit tests because you wrote the code, then a month later someone says, hey, you actually have to write the test for that. So now you're just bored writing a bunch of tests, and it's just kind of the same thing, copy pasting. And then you have all these tests that aren't actually testing the code; they're just testing the mocked data. This forces us as developers to do it the correct way. It's a hassle. It's a little bit more to read. I get that, but we know we're gonna do it, a little bit better, right? It helps us. It's that forcing function, that kind of thing. Okay, so that's it for the unit tests. And I do want to talk about one thing, just something that I really like with unit testing, and you've probably noticed it. You've probably seen these cool red dots over here, and then the this whole progress bar over here on my bottom right. So, hey everyone. So sorry for adding in another edit into this video. So when I was recording this, I completely forgot that the little video of me is in the bottom right corner. So I was talking a lot about, hey, this thing in the bottom right corner. So let's switch to the code, and now you can actually see the thing that I'm going to show. I'm not going to edit the rest of the video. I'm just going to show you a little bit of what I was talking about. So it's this little thing over here on the bottom right hand corner. This is the nCrunch progress bar. The purpose of it is to show you, hey, all agreed, all your unit tests are passing, or how many are not passing. So I can go ahead and put this back down here, and I can go ahead and make a change, and I can say, false dot let's see, should be, was it true? Yeah, there we go. It's just fail some kind of test. And so there we go, right? So we get red over here on the left-hand side, and then we get red over here on the right-hand side, showing that there is a test failing. So that also works in the actual code, not just the tests, but I feel like that's a good explanation. Anyway, sorry about that, and back to the video. Okay, so that's it for the unit tests. And I do want to talk about one thing, just something that I really like with unit testing, and you've probably noticed it. You've probably seen these cool red dots over here, and then the this whole progress bar over here on my bottom right. So this is a tool that I like called NCrunch, N-C-R-U-N-C. I mean, you can see the name down here on the bottom right. So this is a tool that will automatically go ahead and run your unit tests for you. So NCrunch, let me go ahead and disable it so you can kind of see some of the options you get. Oh, nope, I have to go through the wizard again. All right, that's right. Config wizard, there we go. Hey, go ahead, thanks for setting it up, right? I have a ton of cores on this machine. I'll let NCrunch have 4 of them. 4 of my nicely held onto cores, a bunch of threads, etc. So the thing that I really wanted to show you is, yes, run all of my unit tests alongside. So I'm not running any integration tests right here. These are just unit tests, and so because they're just things that are in memory, we can run them, in whatever order. We don't have to care. They have a feature here called RDI. I'm not going to talk about it. I'm not a big fan, but here we go. By default, I have it set up to automatically run these unit tests when code changes. So when you run all of your unit tests, NCrunch is going to say, cool, I know that this one line affects these 4 unit tests. So when you change that line, I'm going to rerun these 4 tests. That's how this works. So it is continuous testing. Oh, and back by default, I say, hey, let's go ahead and run all of them. So that is this tool. That is NCrunch. It is a paid tool. It works on Visual Studio and Visual Studio and Rider. I'm not sure if there is an extension in VS Code, but it is a paid tool. I pay for it because I find value in it. As long as you're able to continuously run your tests and you get that feedback, that's the value add, right? So I'm able to know immediately if, let's say, I change a rating over here for, right, because whatever reason, I immediately know, hey, this test is failing. Oh, I should probably update this down here. Cool, now I know, right? Or you do your basic checking. And so what this means is, if as a developer you're doing some refactoring, it forces you, it reminds you, hey, just so you know, some tests are still failing. Go ahead and make sure they've been run, right? Because it's very easy for us as developers to make a bunch of changes to code and forget to run those unit tests until we commit our code, and then it runs on a build server and all that stuff. I have done that many times, too many. So that's one of the reasons I really like this tool. There are other tools like it, continuous test runners. .NET has something built in. Visual Studio Enterprise has that built in, but you do have to have the enterprise license, which I think I've only worked for one company before when I had that license, and that was Microsoft. So that's how rare it is for me. But yeah, so personally, I pay for NCrunch because I really like it. Oh, sorry, also Rider. Rider has that built in on one of the licenses. I forget which one it is, like some license level. All right, anyway, I think I'm going on too far of a tangent, and so this is the application. These are the basics plus unit tests. So as always, if you have any questions, comments, concerns, etc., we have the YouTube comments right here, and there's social media, Blue Sky, LinkedIn, etc., etc. Just search Programmer Al. You'll probably find me, and that's all I have. So until next time, take care, everyone.